Suppose you have two quantitative variables like I do here. In this data set, there are 16 CEOs numbered from 1 to 16, and for each CEO, I've got an age in years and a salary in thousands of dollars. You could perform XY analysis using a scatter plot and determine if there's an association between age and salary by looking for if there's a cluster of points, either with a positive or negative slope, which might show that people that are older in this sample tend to make more or less money. But if you don't want to use a correlation, scatter plot, regression analysis, there is a simpler approach. You can use Stapplet.com, one quantitative variable, multiple groups, if you just form categorical groups. In this case, I would recommend by age. So if you're looking for an association between age and salary, figure out which variable could, in theory, be your response variable and which could be the explanatory variable. In this case, we would naturally plot this with age as X and salary as Y, because salary is the thing that we think maybe could be affected by someone's age or respond to changes in someone's age by just natural variation of people making more as they stay in positions longer. So that would be just a theory that I would be testing. I might not know for sure, and obviously there's a lot of variables at play. But figuring out this response variable Y and explanatory variable X, or we could also call that a dependent variable Y and independent variable X, figuring that out will help us to make our groups. We want to make sure that we're still studying salary as our primary focus, but we'll group by the different ages. Now this does simplify things down a little bit because we are taking what was a ratio scale measurement with a lot of precision and kind of downgrading it to a categorical grouping. And this will be ordinal, so we will have small, medium, large, or something like that, but just not as precise as we would get with the XY correlation analysis. Now, what I recommend is using Google Sheets, creating a filter table, just highlighting from A to C, and looking for the option to create a filter. That is in more options for me since I don't have room to display all of those. And once you create that, you'll be able to use these sort or filter options to maintain your rows, which is each experimental unit or study subject. We want to make sure those data stay together. But here, for example, I can sort from youngest to oldest, and it will sort everything with it. So CEO 3 was apparently the youngest at 33 years old with a salary of $262,000. Next, I can create my groups. Maybe I want to do 30s, 40s, 50s, and 60s. That's very easy now. Just highlighting those or specifically focusing on the salaries, which is what we want. I'm going to just make two groups. We see a median here, the halfway point in this data set. There's 16 CEOs, so we should have a lower 8 here and an upper 8, so younger and older 8 CEOs with a median of 46.5. So what I would do now is define my groups. I could say 46 and younger. You could also say below median and define that median elsewhere. This would be 47 and older. And in Stapplet, we usually get a chance to name the variable. The variable here is salary of CEOs. You might say a sample of CEOs or get more specific, but I'm just going to keep it simple. And this is in thousands of dollars. So I want to copy and paste the salaries for, there's the younger group and the 47 and older group down here. And we will get to see those side by side. So that's where we took away the precision of having points scattered along maybe a line of best fit. Here, all we can really do is just see that there's the older half and the lowest amount made by someone in that older half of CEOs is still, in that same ballpark as the lowest salary of the younger group. But we do see maybe the trend overall is a lot less variation in this young group. We had maybe a closer grouping there with some outliers at the top and bottom. But then we can verify that grouping with the standard deviation here. Standard deviation is going to measure that width of the spread or disbursement. We can see and confirm that higher variability with the older group, and we can also see and confirm we've got an older average. We can see that median as the middle line is higher, but also in general there's a tendency for these to be higher. That's a great way to do a side-by-side analysis pretty quickly. Maybe just to get an initial look at something, you can always go into more age groups or even that XY correlation to get a more precise idea of how those relate.